Hi, friends. All right, this week we are going to learn about the law of sines and how we can use it to solve for missing sides of any triangle, not just a right triangle. So, to get started, I'd like us to work through this activity. I'll help get you started, and then I'd like you to pause the video and finish it up on your own. So we have a triangle here. And what we're going to do is use our calculator to find the value of each ratio, round to the nearest thousandth. Okay, so it says the sine of A over A. So the capital letters always denote an angle measurement, and the lowercase letters always denote a side length. Okay, and notice the labeling matches up with that anyway. So let's go ahead and fill this in. So the sine of 45 degrees divided by 5.12. We're going to put this in our calculator. Again, make sure that your calculator is in degrees, not radians. To double check that, you would press math, we would not press math, we would press mode. It's on the top next to your second button, and make sure that the word degrees are highlighted. So I'm good there. So we're going to find the sine of 45 degrees, and then we are going to divide that by 5.12. When we're working with the law of sines and cosines, we are going to be using decimals versus simplest radical form. So 5.12, and I get 0.13, and they said the nearest thousandths, tenth, hundred, thousandths, 8. Okay. At this point, I would like you to pause the video and continue finding each of these ratios. I'd like you to work through numbers 1 through 6, and when you come back, we'll talk about it. Okay, welcome back. Let's check your answers. For number 1, you should get 0.138. Number 2, 0.138. Number 3, 0.138. Then if we look at number 4, 0.122. Number 5, 0.122. And number 6, 0.122. So the big question that we need to answer is then, what do you notice? Okay? And what we notice is that every single ratio is the same. And that, ladies and gentlemen, is the law of sines. So when you set up a ratio for the sine of an angle and divide it by the side that's opposite from it, you will get the same thing every single time. So how can we use the law of sines to find missing angle measurements? Well, let's take a look at the triangle that we see in front of us. Okay, what I see is that we need to find the side length of x, which means that we're going to have in our ratio that x. So we would have the sine of 40 degrees in our numerator, because we saw the angle at the top. We'd have that missing value x on the bottom. And what we saw is every single ratio was the same. So that ratio is going to be the same as, say, sine of 65 over 4.88. Or it's also going to be the same as the sine of 75 divided by 5.2. So we can just pick one, whichever one you want. I'm going to choose letter Z. So I'm going to say it's equal to the sine of 75 divided by 5.2. When we have two ratios equal to each other, remember that's called a proportion. A very easy way for us to solve a proportion is to use cross products. Remember, with cross products, all we do is we multiply the two values that are diagonal from each other, and then we divide by the other one. So I'm going to go to my calculator, and I'm going to multiply 5.2 times the sine of 40, hit enter, and then I'm going to divide that answer by the sine of 75. And I'm just going to go ahead and hit divided by. I'm not going to retype in that product that I got, because then my answer won't be as accurate. I'll have rounded it. And then I get an answer of 3.46. There's no units on there, but that is the length of x. Okay. So, again, what this is called is the law of sines. And it says that the sine of any angle divided by the side across from it is equal to all the other ones. Notice the picture, it's color-coded so that you can more easily see what angle to take the sine of and which angle what side length to divide by. Now this is going to be a flashback to geometry. Okay. The law of sines works only in these given situations. One of the given situations is when you're given an angle, then a side. It also works if you're given an angle, side, then the angle next to it. It also works for angle, side, side. That is not one of your congruence formulas or your congruence theorems, but the law of sines works for that. We are not going to practice that while distance learning because there are a lot of different conditions that we have to check for because angle, side, side is not a congruence theorem. But we will work with number 1 here. Angle, side, angle, and angle, angle, side. All right, so let's try a couple of these. We'll do one more together, and then I'm going to have you try 2 on your own. Notice the directions say solve each triangle, round to the nearest tenth. When it says solve the triangle, you have to find every missing measurement. The first thing you should always look for are the missing angle measurements because often those are going to be found by just using the knowledge that the sum of the angles is 180 degrees. So to find angle E right here, we're just going to subtract from 180. So 180 minus 33 and minus 28, and then we'll know our angle E. I left my notes over here. And we get 119. So that's what our angle E is. And what I'm going to do is I'm going to keep a list over on the right-hand side of everything that we find, and then that will be our answer when we're all done. So angle E is 119 degrees. Next, we are going to solve for the missing side lengths E and D. So what I would recommend is looking at your triangle and seeing what angle and side length are you given where you don't have to do any type of rounding or guessing. And what we can see in our triangle is we see that we have our angle F and we have our side length F. So we for sure want to use that in our proportion. So we'll have the sine of 28 degrees divided by 15. And that's going to equal, and it doesn't matter which one we do next. We can do D or we can do E. And let's just go in alphabetical order. So angle D is 33 degrees, so sine of 33, and then side length D is opposite from that. We'll use cross products to solve. We'll multiply these two, hit enter, and then divide by the sine of 28. After you do those two things, you should get that length of D to be 17.4. Notice there are no unit measurements, so we don't have to worry about that. And then we'll check if our answer makes sense when we're all done with our other side. We're going to reuse this ratio right here. The reason is if we use this other ratio instead with the D in it, we'd be using 17.4 and we would be using a rounded answer, and we don't want to do that. Okay, so we're going to keep using the sine of 28 over 15, and we're going to set it equal to, this time we want to solve for E, so we know angle E from up above is 119, so sine of 119 all over E. multiply these two, and then hit enter and divide by what's left over. And we should get side length E equal to 27.9. Now before we box our answer and move on, let's just double check. Again, reviewing things we've learned in geometry. One thing we learned in geometry is that the longest side is across from the biggest angle. Well, the biggest angle is E, and which is the longest side? E. That makes sense. Now, which is going to be the smallest angle? That's the 28. That means the smallest side is 15. That makes sense. D is in the middle there. Okay, I would like you to continue on by setting up proportions to solve the next two triangles. So I would like you to work through letter B, solve for angle P, side length R, side length Q, and then move on to the last example here. Again, solve the triangle means find all the missing measurements, find angle C, as well as side length B and side length A. Okay, so you'll want to end the video, and when we come back, we'll check our answers and we'll look at one formula that we can derive from the law of sines.